Welcome everybody. So we have already studied about the road margins and other cross-section elements. So today we are going to look at design of horizontal alignment. So for that, let's understand firstly what is horizontal alignment. Horizontal alignment is act of change of direction of vehicle movement due to various reasons. There could be various reasons for which the movement of the vehicle needs to be changed. It could be due to topographical limitations. It could be due to obligatory restrictions. Some points that we need to touch by the road could be there. Some points that we need to avoid could be there. Those are known as obligatory points. And there could be some obligatory restrictions. One other aspect of horizontal alignment or to provide change in direction would be if too much length of the road is in straight length, or maybe you can say straight direction, it needs to change for avoiding the passenger to get bored, or it should be attentive, right? So various elements of horizontal alignment, it has different elements. Design speed is one of them. A radius of curve we need to design speed is fixed for different classes of roads and type of terrain available. Radius of curve we need to define. Next is type and length of transition curve, that also we need to define. What type of transition curve we need to provide. Next is width of pavement. It is dependent, as discussed in the cross section element section. Width of pavement is dependent upon type of road or maybe class of road. If it is a national highway, it will have a different width. It will have more or less lanes, and that will decide the width of road. If a single lane road is there, so it will have 3.75 meter. If 3.5 meter is a requirement per lane for multiple lane roads. Next is super elevation. We have to decide. That also needs to be designed. Next is setback distance, right? So let's have a look at design speed. Design speed is the main factor on which most of the geometric design elements depend. It depends upon the class of road and terrain. What type of class of road we are developing or we are constructing, that will decide the design speed of it. And the terrain, what type of cross slope in the area is available, that will decide the type of or maybe the design speed of the road. So terrain and cross slope chart has been given here. Let me put it in a box. If the terrain is plain, if cross slope is 0 to 10%, it is known as a plain terrain. If cross slope is 10 to 25, it is shown as rolling terrain. If 25 to 60% cross slope is available, it is mountainous terrain, and greater than 60 cross slope, it is a steep terrain. So these are the design speeds in roads as per IRC. There are two types of design speed. One is ruling and one is minimum. Ruling is that type of design speed which is used to design the road whenever possible. If some restrictions are there, like intersection is there, or maybe the terrain doesn't support it, so the best case scenario is the minimum speed has to be taken care of for design of speed. So in this table, see here it needs to be written. Okay. So if we have a national highway or a state highway, it will have a design speed of different design speeds when moving in different terrains. For steep terrain, it will have a minimum speed of 30 and maximum of 40. For hill it is 40 and 50. Next is 65 and 80. Next is for plain it is 80 and 100. Similarly, other road speeds are also defined. So you can have a look. You need to remember these whenever it is asked in the question or asked in the paper. You need to answer these accordingly, right? Next is, as far as possible, ruling speed should be used to design geometric elements. However, if site conditions and economic considerations does not permit, minimum design speed is used. This has to be taken care of. Next is horizontal curve. What is horizontal curve? Let's understand something about it. It is a curve in plan to provide change in direction of center line of the road. Whenever the road is moving in a straight direction, and we need to, let's have a look at this. If the road is moving in this direction and there is a mountainous or whatever obstruction is there, right, the road needs to turn to this side. So from this to this, where the straight segment of the road is ending, we need to provide the curve, and that is known as horizontal curve, right? So it is the change in direction of center line of the road. It is represented by either radius of the curve or degree of the curve. So degree of curve is nothing but the degree that is in radians, that is subtended by a 30-meter chain at the center of the curve, right? So degree of curve is the angle subtended by an arc of length 30 meter. 30 meter is taken because it is the length of the chain. It is actually 100 feet, but for this consideration we'll take 30 meter, right? So in this diagram we can have a look. This road is represented by this yellow portion of the road. This is the movement of the vehicle. This is the direction, or this is the center line of the road that is changing its direction. Since there would be some obstruction here, the road needs to change its direction, and hence the curve is provided. Two defining aspects of the curve is, one is radius of curve and next is degree of the curve. In this diagram, if we have a look, for 360 degree, the length would be equal to, we need to find out the value of degree in terms of radius, right? Degree would be obviously in radians, right? So 360 degree would be equal to 2 pi r. 1 degree would be equal to 2 pi r upon 360, and d degree would be equal to 2 pi r d. 360 is equal to 30. If we solve this equation, we'll get d degree is equal to 718 upon r, right? Let me, for clarity purpose, let me do it in the side. Two pi r d upon 360 would be equal to 30 meter. Let's move the meter from here. So we need to find out the value of d. So it would be 360 multiplied by 30 upon 2 pi r. So 215. This would be 360 into 15 upon pi, right? So that will come out to be 360 multiplied by 15 divided by pi. That will approximately come out to be 1718 upon r. That is what has been written here. Here r is in meter and d is in degree, right? Next, when vehicle is on the curve, it experiences centrifugal force horizontally outwards. Whenever a vehicle is, or any object is moving in the straight direction, any object is being rotated in the rotational direction, it will experience a centrifugal force which is equal to mv square upon r, right? You will find this expression in your physics book, 11th or 12th book. If you need a definition of or explanation of this particular expression as well, I'll give it to you. Kindly share it in the comments. Right. Next, when vehicle is on a curve, it experiences centrifugal force horizontally outwards. So centrifugal force is defined as, we'll take the symbol as PC. It is equal to mv square upon r, where m is the mass of the vehicle, v is the velocity, and r is the radius of the vehicle, the radius of the curve. So PC would be equal to w upon g. M is converted into w upon g, and PC upon w is a factor that is used in further equations also. So that is why it is taken as centrifugal ratio. It is also known as impact ratio. Right. Next, the force acting on the vehicle tends to either overturn the vehicle or to skid laterally outwards. Whenever a vehicle is moving in the circular motion or it is traversing a curve, it is bound to two effects due to centrifugal force. One is it will overturn. The straight moving vehicle would be overturning like this. Okay, so that is one effect that will be there on the vehicle, and the other effect would be it would be traversing, or it would be pushing. It would be pushed laterally outwards, and that will cause the accident. So we need to prevent both of these motions to avoid any accident or untoward event. So to maintain the stability of the vehicle, both movements should be counteracted. So for counteracting, there are different things that we can take care of. Firstly, let's look at overturning effect. For no overturning or resisting movement caused by, for no overturning condition is, what is the condition? Condition is resisting movement caused by weight should be greater than the centrifugal force. So here let's have a look. The centrifugal force is acting on the outside of the outside of the curve, and the weight is acting vertically downwards. So it will take movement at A. There are different lengths. B is the center to center distance between the tires, and H is the height of center of gravity. This is center of gravity. Center of gravity, right? So we'll take moment at A. Moment at A would be equal to MR should be greater than or equal to MO. MO is overturning moment and R is resisting moment. For overturning moment, force is trying to overturn the vehicle, that is PC. So it is at a distance of H, right? So PC into H should be less than W is the weight of vehicle, and B by 2 is the half of center to center distance between the tires. So here also we have seen the impact ratio is available. This would be called impact factor. PC by W is the impact factor value. So it should be less than B by 2H. On lateral skidding, it is analyzed such as the vehicle is trying to go outwards. Here the road is in this direction, and the vehicle is, let me show it. The vehicle is on a curve and it is trying to laterally skid outwards, but we need to resist it using the friction of the tires. So how will we do that? For no skidding, frictional force should be greater than or equal to PC. PC is the force that is causing the vehicle to laterally skid outwards, and for frictional force would be F, which is equal to F into W, where F is, what is F? F is frictional coefficient between tire and the road. Frictional coefficient between tire and road, right? So that is what it is. So for no skidding, frictional force should be greater than or equal to PC. If it is equal to PC, that would be the point where if minor force or minor push is there, the vehicle will try to skid outwards. So it should be this F into W should be greater than or equal to PC, and PC upon W should be less than or equal to F. These are the two conditions that needs to be fulfilled for the vehicle to try to avoid to overturn and avoid lateral skidding, right? Since pressure on the outer wheel is, these are some points to be noted. Since pressure on the outer wheel is more, hence rutting ruts are also generally observed near the outer edge on the vehicle. If we take a look at this, since at this point it would be at this particular point it would be having more force, since the pressure on the outside is more, hence it is obviously seen that the rutting or ruts also are observed at the outer edge of the curve. To avoid both conditions, that is, we need the vehicle to not to overturn and not to laterally skid, it should have impact factor value. It should be less than minimum of F or B by 2H. These are the two conditions that needs to be fulfilled for avoiding the overturning and lateral skidding. If F is less than B upon 2H, the vehicle skids before overturning. One of the two conditions will occur before each other. If F is less than B by 2H, vehicle skids before overturning, and if F is greater than B by 2H, vehicle overturns before skidding. So next we'll have a look at super elevation, but that would be the next video. For this video, that's all from my side. Please like, comment, and please subscribe to the channel. This really helps the channel. If you need to understand something else and that I have not explained in this video, or you need to understand some new topic, kindly share the topics in the comment section. I'll also include the QR code or maybe the Telegram link for the channel that I have created for asking the questions, that you can join and share the questions, and that I'll make a video out of it. It should be related to physics, maths, or it should be related to civil engineering concept, or related to, maybe you can ask any question. I'll try to cover it up. Thank you. Have a good day, and please subscribe. Thank you. Have a good day. Take care.